is a lesson about geometric sequences. You've probably already looked at arithmetic sequences and found out that there was a common difference in every case to form numbers in the sequence. A geometric sequence is different. We form numbers by multiplying by a constant, and any term divided by a previous term will form a ratio that's called the common ratio. Here's an example. 5, 10, 20, 40, and so on is a geometric sequence. Notice that term 2 divided by the previous term, term 1, is 2. Term 3 divided by the previous term, 2. Term 4 divided by the third term, also 2. This is designated R, the common ratio. It's a ratio of numbers, and it's common when we have geometric sequence. Now, something to notice about a pattern. Notice that the number 10, which was term 2, was 5 times 2, the first number times 2. The third term, 20, was the second term times 2, or 5 times 2 times 2, therefore squared. The fourth term, 40, came from 5 multiplied by 2 3 times. Again, we can also consider it like a stepping. From 5, we step, step, step to get to 40. There were 3 steps of a common ratio of 2, thus 2 cubed. Not 6, we're not adding, we're multiplying. A general rule, then, is that any term, the general term, is based on the first term multiplied by a common ratio n minus 1 times. This is a formula for geometric sequences. Now notice that the formula relates term, first term, common ratio, and R. 4 total items. 3 of them must be known or given to you to solve for the fourth, just like with the arithmetic case. Let's look at some examples. First of all, are these geometric? If so, find R. Well, if they're geometric, what we've learned is that the common ratio is any term divided by the previous term. So this is 1/3 multiplied by 2 over 1, or therefore 2/3. Now, let's see if we get the same common ratio when we take a different term and divide by the previous one. This is now 1/4 times 3 over 1, or 3/4. These are different than each other. They're not equal. So, no, this is not geometric. This is definitely a sequence. There's numbers in a list with commas. There's a pattern, but it's not geometric, and it's not arithmetic. It's something else again. Let's look at this situation. R equals root 6 over root 2. You may want to pause and think about what you recall from radicals and exponent properties to see how this one works out before carrying on. Alright, what we know is that a radical divided by a radical is the radical of the quotient, so this is root 3. Now let's check the next term. Is it true that 3 root 2 divided by root 6 is equal? Well, if I multiply both top and bottom by root 6 to rationalize, I would get 3 root 12 over 6, and 3 root 12 has the perfect square 4 in it. 4 inside of a radical is 2 outside of a radical. This becomes the number 6 root 3 over 6. The 6's are common factors that cancel. I'm getting the same R, root 3. Yes, this is geometric. I left another term for you here to check, but I think you could even do this one mentally. 3 root 6 divide 3 root 2. The 3's will cancel, leaving a root 6 over a root 2, which is what we had earlier. So yes, this one has the same common ratio. Carrying on, here's a different sort of example. In this case, you're given a geometric sequence with the numbers 144, 48, and 16, and so on according to that pattern. You're asked to find R and T7, the 7th term. Okay, well, I know that A is 144, and R is any term divided by the one previous. 48 and 144 are both divisible by 48. Take my word for it. R is 1 over 3. Let's just check the next term. 16 divide 48. They have a common factor of 16. It's also 1 over 3. So yes, it's geometric. Now I have R. t sub n for any term is based on the first term times a common ratio n minus 1 times. So t7, what that implies is n equals 7. A, 144. Common ratio that we just found is 1/3, and the exponent is 7 minus 1, or 6. So this is 144 over 3 exponent 6, and that will reduce to 144 over 729, or 16 over 81 by removing common factors. You can check that work with a calculator. Let's move on. Here's yet another example. There is a geometric sequence, and in this case you're told the second and the seventh term. They didn't tell you term 1, and they didn't tell you the common ratio. Well, we're going to have to take a little bit more work here to get through this. I know that any term is based on the first term multiplied by a common ratio n minus 1 times. So 3 equals a times r exponent 1. This has two unknowns, so I can't carry on further yet. Now let's look at term 7. Term 7 will be a r exponent 7 minus 1. So 1 over 81, the term, is a, which we still don't know, times r, which we still don't know, exponent 6. Now, notice, because I have ar here and ar to the 6, I may want to rewrite this as ar times r exponent 5. And what I just underlined here is 3, according to what's written here. So I'm going to substitute this knowledge over here. And I'm going to get 1 over 81 then equals 3 r exponent 5. Now I only have one unknown, so I can solve. R exponent 5 is 1 over 243. So r is the fifth root of 1 over 243. 243 is 3 exponent 5. And so this will become 1/3. There is your r value. You need some good exponent law knowledge to get through some of these problems. Lastly, a. Well, let's work with this information we had here. T2 equals a r. Alright, so T2 is the number 3, a is unknown, r is 1/3, and that's going to lead me to saying, well, a must be 9, my first term, 9. Got one more example to work out with you, and this is a wording issue here. This sometimes comes up. This question says, insert 3 geometric means between 3 and 7. Here's what they mean. There's 3, there's 7, in between it are 3 numbers, and these numbers are such that this is a geometric sequence. So 1, 2, 3, 4, 5. 7 is term 5. And using t subscript n equals ar exponent n minus 1, should also list that a equals 3, let's substitute. I'm going to be able to say 7 equals 3. I don't know r, but if I'm on term 5, n is 5, so this is 5 minus 1. Therefore 7 divided 3 equals r exponent 4, and r itself, to remove the exponent 4, I'm going to take the fourth root of 7 over 3, which is an ugly irrational number, but at least I know a common ratio, and what I'm going to do now is I'm going to multiply by a repeatedly to form these numbers. Term 2 is a times r. So term 2 is going to be 3, fourth root, 7/3. And we'll just leave it like that. Term 3 is going to be a r squared. So 3 times the fourth root of 7/3 squared. Now, remember that a fourth root is like exponent 1/4, and that is being squared. So I can simplify that a bit more and say, well, this is like 3 times 7/3. 1/4 times 2 is 1/2. So I can call that square root. And lastly, term 4 is a times r multiplied out 3 times. So 3 times the 4th root of 7/30 cubed. And actually, that's as simple as I can really get that. I can call it an exponent of 3/4, but that's not really any simpler or better. So really, this term right here, and this term right here, and this term right here, they represent my 3 geometric means in between 3 and 7. Kind of ugly numbers, but according to the pattern of geometric sequences, that's what you get. Good luck with the lesson.